Welcome back for lesson 3.4. So we are going to extend our learning on polynomials just a little bit further. And we're going to learn some tricks of the trade to be able to find our zeros and to be able to factor a polynomial completely. So it's pretty exciting. This is it. Okay, so I'm going to go and shade. It's so nice and bright out today, but just one moment. Okay, so let's start with question number 12 on page 265. It says, show that the given value of x is a zero of the polynomial. Use a zero to completely factor the polynomial. So I'm going to use x equal to 2 as a factor. And I am going to use synthetic division. So 1 is my coefficient on x cubed. I'm missing an x squared term. We have a -7 and then a 6. So I'm going to bring that 1 down. So 2 times 1 is 2. And add that. And then 2 times 4 is, 2 times 2 is 4. And we get a -3, and then 2 times -3 is 6, a -6, and we get a remainder of 0. Okay. So this becomes the x squared plus 2x minus 3. So I'm just going to write it as this. And then we have our x equal to 2, which means that x minus 2 was the other factor. And then we can actually factor this further because we know that this x squared can possibly be factored. So we can do some guess and check and look for factors of a -3, which are a positive 3, and a -1 will give me a -3 multiplied. And then when you add them, you get a positive 2. So it looks like x minus 2, x plus 3, and x minus 1 are all of our factors. And let's just check that in Desmos. And there it is. And if we click on it, we can see there's my -3, there's my 1, and my 2. Excellent. Okay, let's look at, I'd like to do number 15. Number 15 is asking us to do the same, to show that 2/3 is a factor of is a zero of the polynomial, and then factor the rest. So 2/3, I'm going to again use synthetic division. So we have 3, a -2, 3, and a -2. So when I multiply 2/3 times 3, I get 2. And I add these, I get 0. 0 times 2/3 is 0. And I add those and I get 3. And then I multiply 2/3 times 3 and I get 2 again. I add those, I get 0. Cool. So we have 3x squared plus 0x. So there's no middle term. Plus 3. Okay. So we have 3x squared plus 3. And then x equals 2/3 is a 0. So if we multiply both sides by 3, we get 3x equals 2. And if we subtract 2 from both sides, we get, this is one of our factors. So 3x minus 2. And actually, we could have originally done this in the grouping method by factoring out an x squared. We would have had 3x minus 2 left over. Mm-hmm. And then a 3x plus 1. So 2 squared. And then x squared plus 1. So let's just see here. 2, 0, 0, 3. Okay, so this actually factors out front a 3. So we have 3 times 3x minus 2 times x squared plus 1. So x squared. Okay. I think we did this. So let's just. It's 3x minus 2. Then we should just have an x squared plus 1. Why does this have? Let's go to decimals and just check our work here. Number 15. And so let's look at our original 3x cubed minus 2x squared. Oops. Plus 3x minus 2. Let me turn off my red one. Because it just has this one real 0 here. Yeah, because of that. Okay, so let's just look at our table of zeros. And let's see if 2 is a 0. It is. Yep. So we are good. So let's, I wanted to look at number 24 next. So 24 says, find all the real zeros of the polynomial. And this is our polynomial I have written down here. And so we are going to use a technique that is taught in this lesson on page 261. Let's just go back to the book real quick, just so you can see this, how this is written. So on page 261. So it's called the rational zero theorem, and says a non-constant polynomial function of degree n has at most n real zeros where each zero of multiplicity k is counted k times. Okay, so we can find all of the possible rational zeros. So if we have our polynomial, it's a polynomial with integer coefficients, and p divided by q, okay? So if we look at all of these rational values, where p are factors of your constant a0 and q are factors of an, your leading coefficient. Okay, so p divided by q. So we're looking at all the possible factors here. So we're looking for possible factors where P are possible factors of your 3 over your possible factors of 2. So plus and minus and plus and minus. So you could have 3 by itself, 3 over 1. You could have a negative 3 over 1. You could have 3 over a negative 2. You could have 3 over 2. You could have 1 over 2. So all the factors of plus or minus 2 times 1 essentially, and plus or minus all the combinations of 3 times 1. So we just need to find 1 to get us started. So that's where if you can just find 1 of these that will work in Desmos, then you can get started on factoring the rest. So our rule is we're looking for factors of P over Q, where P are factors of A sub 0 over A sub n. So this is your constant over your leading coefficient. Leading coefficient. So we're going to go to Desmos, and essentially we know that in Desmos it will show us all the factors that we want, but I want to factor this out. And so we just need to find 1, and then you're going to show me the rest by hand. So let's go and look at this list in Desmos here. Okay, so note that this is number 4. And so we're going to look at 2x cubed plus 3x squared minus 8x plus 3. And we're going to look at our list here. And oh, I see when 1 pops up right away. So if 1 pops up, then you don't even have to check your list. So and I'm not saying the number 1, but if there is a 0 that pops up, you can start with that. And it looks like 1 is a 0. So we know that 1 is a 0. So that means that x minus 1 is a factor. Okay. So now we can go back to our paper and use that to get us started with a synthetic division. So, so I know that 1, so x equal to 1 is a 0. Okay, so I'm going to put in my coefficients 2, 3, minus 8, and 3. Okay, so I'm going to bring down my 2. So 1 times 2 goes here, 5. 1 times 5 goes here, and negative 3, and 1 times negative 3 is a negative 3 and 0. So that 0 validates that yes, this is a factor. And then what's left over is 2x squared plus 5x minus 3. 2x squared plus 5x minus 3. Now, if you can't, if you're like, oh, I'm not great at factoring, then you could use a quadratic formula, but we could try to factor this last piece into 2x and x, and we need a positive 5x. So a negative 3 would be a 1 and a negative 3. I'm going to do a negative 1 and a positive 3. So these multiply to 6x minus 1x gives us a positive 5x in the middle, and this is a minus 3. Okay, and then we have this has to come down. So our final is the x minus 1 here, and then 2x minus 1 times x plus 3. Now, you can check that by typing this exact thing in and making sure that it makes the same graph of our original polynomial. That's one way to check it. So I'm going to type in our original polynomial, that we had. That's in red right here, number 24. So it's already here. So I'm gonna just type in the factors x minus 1 times 2x minus 1 times x plus 3. And sure enough, it's overlaid. So that's how you know that this is the factored form. Pretty cool. Okay, so let's try one last one here. We're really cruising along in chapter 3. 36 is the last one that I'd like to look at. It says, find all real solutions of the polynomial equation. Okay, so for us to apply any of our strategies, it all has to be equal to 0. So 3x cubed minus 7x squared plus 5x minus 1 equals 0. Okay. So it doesn't look like we can use our 4-term grouping by factor by grouping. So I'm looking at possible zeros of a -1 over plus or minus 3. So we've got plus or minus 1, and then we've got plus or minus 1/3 are the possibles. So I'm going to go to Desmos and find one of them that is a 0. Nope, this is number 36. And we have 3x cubed minus 7x squared plus 5x minus 1. Okay. Let me turn off my other groups here. Okay, and I'm going to make my table. And it looks like the number 1 is a 0 again. Ooh, we got lucky. So 1 is a 0, so that will get us started in our synthetic division here. And so I'm going to write down my coefficients and get started. So 1 times 3 is 3. That adds to make a -4. 1 times a -4 is a -4. That adds to make 1. 1 times 1 is 1, and that adds to make 0. We're just validating that that is a 0. And then what's left over is this is going to be my constant, and I wrote a dot. That's really a +1. And so that's going to be an x term, and that's going to be an x squared term. So we have 3x squared minus 4x plus 1. Times, we know that this is a 0. X equal to 1 is a 0. Zero. And so that means that x minus 1 is a factor. Now, we could try to factor this. And they have to add to make a negative and multiply to make a positive. So I'm thinking a -1 times a -1 multiplies to make a +1, and then you get a -3x, and then -1x gives you the -4x in the middle. And then we have x minus 1. So my zeros, when we look on Desmos, should be at x equal to 1, and it's happening twice, right? So this is really x minus 1 squared. So the multiplicity is 2, so it's going to touch here, just kind of bringing back what we learned in the other lessons. And then we have the 3x minus 1, which is x equal to 1/3, which is going to be a cross. It's going to cut through. So let's go put this into Desmos and just check it out. Putting what we learned into, okay. Oh, and actually look at, so we crossed here and actually, yep, at 1, 0. And notice that it doesn't give me this right here because I didn't originally type it in as a y equal. I don't know if I can do that. No. So I'm going to just copy it. And I'm going to say y equals, and I'm going to paste it. Okay, now I did it there. So now when I click on it, it should show me all of those. If you do a y equals, then it knows that you're going to be looking for this intersection. So there's my y-intercept. There is my negative or my positive 1/3. There is my 1, 0, my intercepts. And it does just touch here. It comes down and touches and then goes back up. Awesome. And you can see everything we've put together because our leading term is a cubed. So we know it's going to be a face down, face up. And then our end, what our ending value or look like is on our graph. Our 3 is a positive on the leading coefficient. So it's going to be ending face up here. Very cool. Very cool. So that kind of puts it all together. So catch me back for lesson 3.5. We are going to get into some complex numbers and talk about zeros that are not real zeros. So we're almost to the end of chapter 3. Catch me back.